Alright, in this video I'm going to talk a little bit about using permutations. And the basic idea is that you use permutations when you're counting without replacement and the order in which things occur matters. So these are things that you're going to have to take into consideration when you decide to use permutations or also combinations, which I'll talk about in another video. The basic formula for permutations involves factorials. If you need to see some factorial stuff, we'll practice some here, and I've also got some other videos with that. But it basically says if you have n objects to choose from, so that's what the n means, you have n objects to choose from, and it says what we're going to do is we're going to pick r of those objects. It says this is the formula that you use. Use n factorial over n minus r, all of that simplified, then factorial. Okay, so I've got a little example, but maybe before we do our examples, let's just mechanically do a couple of the formulas here. So again, the basic formula is n factorial over n minus r factorial. So if we want to do this expression p53, you'll have 5 factorial on top, and then you just put in parentheses, you subtract the two values, 5 minus 3 factorial. Well, again, on top, that's 5 factorial. 5 minus 3 is 2 factorial. And you can check that 5 factorial is 120. 5 times 4 times 3 times 2. 2 factorial is just 2. So we'll simply be left with 60. Okay, so again, if you need to see some factorial stuff, take a look at my other video. I'm going to try to simplify these a little faster just so we can actually get to the actual word problems. So P6 of 6, on top you have 6 factorial, excuse me, then on the bottom you have 6 minus 6 factorial. Well, again, 6 factorial, 6 times 5 times 4 times 3 times 2 times 1. On the bottom we have 0 factorial, but remember 0 factorial is actually defined to be 1. And we just said that 5 factorial was 120. That's what we had on the top part of our other fraction. So if you multiply that by 6, you'll get 720. Okay? And our last one, we would have 10 factorial. Again, we have to subtract them. 10 minus 4 factorial. This is 10 times 9 times 8 times 7 times 6 times 5 times 4 times 3 times 2 on top. On the bottom, 10 minus 4 is 6 factorial. So I have 6 times 5 times 4 times 3 times 2. Well, you can actually cancel out the 6's, the 5's, the 4's, the 3's, and the 2's. So all we're left with is the top part, which is 10 times 9 times 8 times 7, and this number turns out to be 5,040. Okay, so let's do a couple, a couple of word problems to make some sense out of this. Hopefully, a little bit more. Okay, so suppose you're at the racetrack and there's 10 horses running a race, and you want to know how many different ways first place could happen, second place could happen, and then third place could happen. So, you know, if different horses come in different places, that would be considered a different outcome. So maybe you're going to buy a ticket, and if you win, to win you have to get the exact order in which the top 3 horses finish. Okay, so this is going to tie into probability here pretty soon. Well, again, in this case, it's a permutation because I'm counting without replacement. If a horse comes in first, it can't come in second or third. Once it finishes, it's done, so I can only kind of count an object one time. And certainly here the order matters because we're saying, well, you know, if horse A comes in first, B comes in second, C comes in third, that's going to be a different outcome as if horse B comes in first, horse C comes in second, and horse A comes in third. Okay, so I have 10 total objects to choose from. There's 10 horses, but I'm just interested in picking out 3 of those, the top 3 places. So this is going to be 10 factorial, and you kind of hopefully saw the pattern. You can just subtract the 2 numbers on the bottom. You'll get 7 factorial. This is going to simplify to 10 times 9 times 8. Okay, so maybe work this out if you're not quite sure about this to see where I'm getting that. And that comes out to be 720. So there's 720 different ways that 10 horses could finish the top 3 places. And notice really all you're doing is using the multiplication principle here. If you think about the number of ways that the first horse could finish, well, there's 10 possible horses. Well, for second place, one of them is already finished. There's only 9 horses left. And then for third place, there's only 8 horses left, which would leave you with 8 choices. So permutations are really just kind of a simplified way, or just, it's basically you're just using the multiplication principle. That's all it is. Okay, so it's nothing, you know, it's nothing really that new if you've been using the multiplication principle. Okay. Okay, so in this problem it says suppose that there are 20 students and we're going to pick somebody for president and for vice president of our class, and we want to know how many different ways we could have a ticket with a different president and vice president. Okay, so again here we're sampling without replacement, because if you get picked for president you can't also be vice president. You have to be one or the other, so we're sampling without replacement. And here the order matters because maybe I pick president first. Okay, well, once I pick president, the next person automatically has to be vice president. Okay, so if I'm president and you're vice president, that's a different ticket than if you're president and I'm vice president. So again, we use permutations. There's 20 objects to choose from, and I have to choose 2 of those. Okay, so that's 20 factorial over 20 minus 2 factorial. Okay, so that's 20 factorial on top, 18 factorial on the bottom. If you were to write things out and cancel, you would see that you would be left with 20 times 19. And if you multiply out 20 times 19, you'll get 380. So with a class of 20 students, there's 380 different tickets where one person is president and someone else is vice president. Alright, so one more example here of using permutations. And in this problem, it says a softball team has 10 players, and we want to know how many different batting orders are possible if everyone gets a chance to bat. Okay? Well, in this case, again, we're sampling without replacement, because if I get to bat first, I don't get to bat 5th as well. I go once and then everybody else gets their turn. And the order matters because, well, it's going to be a different ordering. So maybe I go first, you go second. That's a different ordering than if you go second and I go first. Okay, they'd probably put me last. I think they tend to put the bad people at the tail end. So that would definitely be a different ordering than if I was going first. So in this case, we're sampling without replacement. The order does matter. There's 10 objects to choose from, but I'm going to choose all 10 objects in this case. Okay, everybody gets to bat. So it says we'll have 10 factorial on top. On the bottom we get 10 minus 10 factorial. So it says on top we have 10 factorial. Again, on the bottom you get 0 factorial, but 0 factorial is defined to be 1. So it says really we have 10 times 9 times 8 times 7 times 6 times 5 times 4 times 3 times 2 times 1 orderings. And again, that makes sense if you think about this multiplication principle. The first choice you would have 10 people to pick from, then you would be followed with only 9 remaining, and then 8 remaining, 7 remaining, 6 remaining, etc. down the line. So we are just using the multiplication principle here. And check my arithmetic here. It looks like this turns out to be 3,628,800 ways that you could have your different batting orders with just 10 different people. So I hope this this video helps with permutations and counting techniques. If you have any questions, let me know. I'll also do a follow-up video that involves using combinations to count the number of ways something can occur.